In this tutorial, we will focus on calculating a local minimum or local maximum. For an example, we can consider just a polynomial, like a second order or third order polynomial. We'll let x here equal some constant, and let's say that y is going to be equal to x squared minus 2x plus 5. And so we can calculate this and we get some value for y, some value for x. We could go in here and create a parametric table. We want both of those in there. 10 rows is fine. And let's let x vary from -5 to +5. Let's try that. And we have to go back here and comment out that x, calculate, and let's take a look at that plot, x on the x and y on the y. So here's what our function looks like if this was some function that we needed to find the minimum of. Now, this is a very simple example. If we know the function, we can just take the derivative of it, set it equal to 0, solve for that x value. But most of the time we are left with something that's much more complicated, and that's a function of fluid properties. It's a function of all these other parameters. Maybe we're looking for we're looking to maximize the efficiency of a power cycle, for instance. And so we could just zoom in here. We could say, well, we know it's between 0 and 2, so let's go back to the table and let's alter the values between 0 and 2 and successfully just keep zooming in on this. And let's do another plot there just to show the difference between the two. So in this case, I'm only doing a subset of that, so let's just do a new plot, actually. So now I'm left with this plot, and I can see, well, it's between 0.5 and 1.5. So I could keep zooming in and keep zooming in, or I could just put a whole bunch of data points. Instead of 10 rows in that table, I could make this 100 rows or a couple hundred rows. But the calculation functions in EES include this min-max. And so if I go to min-max, well, first of all, if I comment this out, or I comment this back in, and I try to go to the min-max function, it's going to give me an error. And the reason why is because it doesn't have any degrees of freedom. I've only got two variables in here. I've got two equations, so there's no way that I'm going to be able to maximize anything. I can't change anything. Everything's fixed. So in order to optimize, I have to have something that's floating, and you can think of this in a similar fashion to as what we had in this parametric table, where we had to comment out the x in order to then evaluate x at different values, and 10 values specifically, because that's how big our table was. So in this case, if we comment this out and go back here to calculate min-max, this is the dialog box that you'll see, and you can either choose minimize or maximize, and the most common error I think that people will encounter is forgetting to change that radio button from minimize, which is the default, to a maximize. But let's, in this case, with this function, we do want to minimize, so we'll keep that on minimize. We want to minimize x. No, we want to minimize y by changing x. And so x is the independent variable. X is what we are changing. And if I just hit OK, there's different methods on this numerical optimization that's going on in the background. But if I hit OK, it's going to tell me you need to set some bounds for this. You need to give EES a logical starting point. We can't use the entire negative infinity to infinity spectrum. So if I click on yes, and I could have gotten there, by the way, just clicking on this bounds button. So x is what I'm changing. I know a minute ago that it was between -5 and 5. And I think 1 is a decently good guess, and so I hit OK, and now when I click OK, then it finds that minimum for me. And once I hit continue, then it generates the solutions window using that value for x, which is my optimum value. And so this is a very simple example, but hopefully it illustrates the process when you have a much more complicated set of code that you're still going to go through those same steps. You have to first assume something for that. If you're changing an intermediate pressure, for instance, in a regenerative Rankine cycle, then you have to use something for that, go through all the calculations, and then go back, comment it out, and do this min-max function. So just to show you what kind of error you're going to get if you choose min when you meant max, or max when you meant min. In this case, we wanted to minimize this second order polynomial, but let's say that we incorrectly chose to maximize. Now these bounds are still -5 to 5. Everything's the same there. But when I hit OK, it's not going to go to that optimum value, which gave me my minimum target y. It's going to go to anywhere in those bounds that gives me the largest y, because now I'm maximizing it. And not surprisingly, it goes to one of the two extreme ends of the bounds that I chose for x. And so you're going to choose bounds, and if you find that the solution gives you one of your bounds, then most likely you forgot to choose min when you meant max, or vice versa. Okay, that concludes this tutorial. Thanks.